Hi everyone, welcome back to Data Nutshell. Today let's dive into topics like file retrieval, redundancy, and tiering on cloud storage. So when you open a file stored on your laptop, it feels simple. You double click and the file appears. But in the cloud, the files usually don't sit in one disk. It's not like a book resting on a shelf. Instead, your file is broken apart into multiple chunks, and those chunks are distributed across multiple disks on multiple servers. And then, when you need your file, those chunks are reassembled. Today, let's go behind the scenes and see exactly how this works. So, why is retrieval on the cloud different? On your laptop, your file has a direct path, and the operating system knows which disk sector holds which byte of your file. When you need your file, the OS just fetches them in order and gives you your file. But in the cloud, there is no single disk or single path. Your file is usually spread across hundreds of servers, and those servers could live in different racks in a data center or even across data centers in multiple different cities. And disk failure is happening constantly in data centers. Thousands of disks fail every day. So, cloud storage has to be designed differently. Instead of relying on one fragile copy, cloud storage relies on concepts like redundancy. So let's revise the concept of metadata. Metadata is the information about the file. It's not the actual file itself, it's just some information about the file. So you can think of metadata as the table of contents of a book. A book is usually written as chapters, and the table of content page in the very front tells you on which page which chapter starts. The same is the concept of metadata. Your file is split into chunks, and the metadata records which chunk exists where. So when you request a file, the system looks up the metadata to figure out which server holds which chunk, and it knows how to stitch them back together in order. Without metadata, your file would be lost in chaos. Why do we split files at all? So, the concept of chunking is splitting the files for efficiency because those smaller pieces are actually easier to store, easier to move, and easier to protect. Think of a 500 MB presentation. If you upload your 500 MB presentation to one disk on the cloud and that disk fails, recovery of that 500 MB presentation would be very time consuming. But on the cloud, we usually split the files into chunks, and those chunks lie on different servers. So, say your 500 MB presentation, for example, is cut into 128 chunks. Those 128 chunks lie on 128 different servers. Even if few of those fails, the recovery would be very much less time consuming because the size of those lost chunks is much smaller, and each chunk is small enough so that if few go missing, the recovery is relatively easy. One more important advantage is parallel retrieval, because if that 500 MB is hosted by one single server, retrieving it from that one single server would also take much time. But if it is spread across dozens of servers, those dozens of servers can actually send you back those chunks in parallel, and then those chunks can be reassembled and the file can be showed to you within milliseconds, and the whole process becomes much faster. So let's see, when you request a file on the cloud, what happens. Say you go to your file and you click open. Your request would go to the cloud storage system. Metadata lookup would happen. That is, the system would check that metadata and see where those 128 chunks are stored, which servers host those 128 chunks. It will then collect those chunks from those servers, and those dozens of servers will send back those chunks in parallel at the same time, and then the system would stitch those together in the right order. And when that is complete, your presentation is streamed to your device, and all of this happens in milliseconds, and it all feels almost instant.